So in this video, I'm going to do an example on how to find the centroids of a region, lamina, and so the exercise is to find the centroid of the region bounded by the curve y equals 1 minus x squared, the x-axis, and the y-axis. So 1 minus x squared is this parabola. So it's it's the x squared parabola, then inverted, and then so x squared parabola is like that. Inverted would be like that. That is minus x squared. You shift it up by one, so 1 minus x squared is like that. But you only want the region enclosed by the x-axis and the y-axis, right? Okay, so we are talking about this region, right? X-axis and y-axis, right? And in the so you should say in the first quadrant, just to be safe. So it's first quadrant. So this is the region we're talking about. So you want to find the center of gravity or the centroid. So you want to find x bar and y bar. The x coordinate is x bar and the y coordinate of the centroid is y bar. Okay, so we have a formula for that. Okay, so x bar is integral x fx dx, right? And divided by integral of f of dx. This is actually the area of the plane, right? At the region, and then y bar is slightly different, 1/2 absolute value of fx squared dx, right? And then again divided by the same area integral. Because both of these things have the area as common, the integral of f of x dx, it might be a good idea to just find it out first. So first, let's find this space, f of x dx, right? Okay. And so what I'm going to do is I'm going to say find integral of f of x dx, which is to find the integral of 0 to 1 of the function, which is 1 minus x squared, right? So this is a very easy integral, right? Because the integral of 1 is x, integral of x squared is x cubed over 3, 0 to 1. So, and then you plug in 1 here, you get 1 minus 1 over 3, and we plug in 0, you get 0. So the answer is 1 over 1 minus 1 over 3, which is 2/3. So we actually managed to find both the denominators of the x bar and the y bar, and that is 2/3. Okay, now let's try to find the easier one, which is x bar right away. So that will be integral of x fx dx. So that would be the integral of x times f of x is what? The curve, which is 1 minus x squared, right? Okay, dx, and you divide it by integral f of x dx, but we already found that that's the area. That's 2/3. You divide by 2/3. So you take the 2/3 up, you get 3/2. And now, how do you integrate this one? Well, it's a polynomial, so the easiest way would be to just distribute the x. So if you distribute the x, you get x minus x cubed and integral. So now we have 3/2, and then the integral of x is just x squared over 2 minus integral of x cubed is x to the 4th over 4. And then when you plug in the limits, okay, so when you plug in the limits 3/2 and then you put 1, you get 1/2 minus 1/4, right? Which is equal to 3 over 2. And then when you plug in 1, you get 1/2 minus 1/4. So 1/2 minus 1/4 is the same as 1/4. So 3/2 times 1/4, which is equal to uh, 2 times 4 is 8. So 3 over 8. So x bar is 3 over 8. So basically what it says is that if you take this area, right, if you take the centroid, the distance from along the x-axis to the centroid is 3 over 8. It's 3/8. Okay. Okay, now let's find the y bar, and it's a similar trick. Okay. The equation is a little bit you need to be very careful about the 1/2 here. People miss this 1/2 quite often. So remember to put that in 1/2 times absolute value of fx squared dx and then divided by fx dx. And we already know this all the time. So this is the area that we found to be equal to 2/3. So let's put that in first. So it's divided by 2/3. And let's take the 1/2 outside. It's a constant, and then you need to square the function. Remember to do that, okay? So the function is 1 minus x squared. You square that and take dx. So if you simplify that, you get 3 over 4, right? Okay, so 3 goes up to the front, 2 times 2 is 4. And then when you distribute this, it's a square. So it's a square of the first one, 1, minus twice the middle term, the product of the middle term, so minus 2x squared, and then square of the second piece, which is x to the 4, and you still need to integrate that. So 3 to the 4th, when you integrate this one, you get integral of 1 is x, integral of 2 2 times integral of x squared is x to the 3 over 3, and the integral of x to the 4 is x to the 5 over 5, and then you put the limit 0 1, and when you put the top limit, you get, so 3/4, 1 minus 2/3, so this becomes just 1, and this also becomes 1, so you get 1/5. When you put the bottom limit, you just get 0 because everything becomes 0. So 3 over 4, 3/4, and then we take the common denominator 15, 3 and 5. So here when you multiply, you just get 15 minus here 3 times 5, 5 times 2 is 10, and then 5 times 3 and 3 times 1 is 3, and 3/4 is outside. So 15 minus 10 is 5, 5 plus 3 is 8, 8 over 15 times 3 over 4. So now 4 gets cancelled with 2, 3, 5. So the answer is 2/5. What it says is that, of course, that if you take the y coordinate, we found the x coordinate of the centroid to be 3/8, but we found the y coordinates of the centroid. That means the distance from the x-axis to the centroid is 2/5. Thank you very much for watching. That's it for this.